Hello, everyone, and welcome to another session with Analytics Velocity. The focus of today's session is to try and cover one of the preliminary topics of predictive analytics, which is the whole concept of linear regression. So, linear regression was actually one of the original forms of regressive techniques that were created, and a lot of theoretical work has been done on that over time. As we have progressed into analytics and advancements in this field, further regression techniques have come on. But our focus today will be on linear regression and how it is used in day-to-day practice to solve business problems, and what possible applications can there be in interviews also when it comes to this, because there are definitely areas which we will cover. So, as part of the first area of discussion, what I will do is I will take you through a basic idea of how a regression actually works. And basically, linear regression essentially says what is a relationship between two variables on a one-on-one basis. So if I consider, for instance, quantity and price, which we know are the two basic components of demand, how would price and quantity be modeled together as part of a demand equation? So a regression equation is always of the form y is equal to beta 0 plus beta 1x, where beta 1 essentially shows you how much is my demand changing as my price is changing. So that is something obviously all companies will want to know, because they'll want to know how responsive is their demand in response to a small price change. Beta 0, on the other hand, also has an intuitive explanation in that it shows that how much of demand is actually getting generated when no price is being charged at all. So basically, how much is the amount of organic demand which the company is benefiting from? It is this key equation which determines the crux of linear regression to begin with. Your one-on-one relationship between demand and price is an example, but this can be applied to a host of other variables. It can be between smoking and cancer. It could be between the amount of alcohol consumption and accidents, whatever it may be. So now I will actually show you a brief description of what linear regression looks like from the theoretical perspective. So let me just quickly share my screen, take you to the whiteboard. So where does linear regression come about? So if we take the same two variables, let's say we consider price of a commodity on the vertical axis of this 2x2 graph, and if we consider quantity on the horizontal axis. So now if I was to plot a bunch of points in relation to price and quantity, they would probably look like this. If you, through no theoretical understanding, but just through basic business expectation, you would expect that the points plotted in this framework, 2x2 framework, would float downwards like this, because there would generally be a negative relationship between price and quantity. So that is basically what we say is the correlation. The correlation essentially tells you what is the relationship between price and quantity, what is the strength of that relationship, what is the direction of that relationship, and that this is something which we will go in depth and discuss when we actually discuss linear regression at Analytics Velocity. Now, suppose if I want to know how much my quantity changes as my price changes, then the objective would be to draw a line as indicative as possible through these points. It is this straight line which we basically refer to as our linear regression. This regression line has actually had considerable debate about it, because there are several assumptions attached to it, and we will explore that in detail at Analytics Velocity in our day-to-day courses, how these are asked in interviews, and how they're applicable in fine-tuning models on a day-to-day basis. Now, this is just one aspect of regression which we are covering here. In relation, there'll be several others which we will cover as well during our course. In a linear regression, one of the core focuses is that what is the mistake which this line is making? That is, clearly this line is not passing through every point. So this gap between the line and the point is basically what we refer to as the error, denoted by this symbol. So our objective going forward would be to try and reduce this error as much as possible, and reduce this error way down, so as to get an optimal line of the form y is equal to beta 0 plus beta 1. So it does seem that there are certain aspects more which we need to cover in terms of how do we get the best beta 1? How do we get the best beta 0? How do we determine what is the optimal amount by which demand changes when price changes by 1 unit? And how do we minimize this error term? That is precisely what we will cover through a technique known as OLS, or ordinary least squares. This is a technique which is rarely discussed today. It is rarely covered in much of what is currently available in regular content, but it is actually one of the origins of linear regression. And it is this technique which we will cover in detail when we start discussing linear regression as part of the course. And it will be instrumental for you in your understanding of linear regression, in tackling interviews, and in fine-tuning models for clients on a day-to-day basis. There will be several assumptions which we will cover, and that will be important not only in this basic understanding of linear regression, but also through the run-through of the code. So how do we actually conduct linear regression in practice? Is there a way which we can analyze a data set? So let me show you a real world data set, and we'll be exploring tons of these when we actually go through our course in analytics velocity. For instance, if you see here, we have a data set in relation to the age, gender, and spending of customers for a particular mall. And the mall is trying to ascertain the spending score of each of these customers based upon their gender, their age, and their annual spending. So how can we model this possibly and tell our client, who might be the mall, as to how much is my spending score changes when each of these units change by a certain amount? Now that is a very intuitive business result. So what we will do is we will not do this manually. We will have our basic understanding in mind based upon what we have discussed in our theory, and we will directly dive into one of our statistical tools. So we will do this in both R as well as Python. And this is the R code which we will cover in much more detail during our course at Analytics Velocity, where we will apply a variety of functions to manipulate the data set, to remove values which are outlandish and extreme, to remove missing values from the data, and actually undertake our linear regression. I will also teach you important topics like the partitioning of data, the scaling of data, all of which are important in the training of an effective model to predict the future. And we will also go assumption by assumption as what are the key factors determining OLS, if you recall the term which we had spoken about earlier, ordinary least squares. All these are very important in fine-tuning any model. And it's also important as part of your interviews because it is these assumptions which people get quizzed on. So this is a very brief overview of the code. We will be going into this code in depth, covering every possible aspect of a linear regression, how to formulate a model, how to clean up data, how to transform variables, how to evaluate a model, how to fine tune them through a variety of metrics, which we will discuss. So this is a very basic run through of one of our preliminary topics. We cover a variety of other topics like tree-based methods, boosting methods, classification techniques, time series as part of the analytics velocity curriculum. So remember, this is not at the end of the day just part of a modeling exercise. We are trying to help a client out. So we will also discuss how these modeling outputs actually work in a business context, and what we need to do to try and apply these outputs so as to explain to a client what are our model outputs, how are they applicable in their business environment, and how we can help them as a consultant going forward. So this is a basic overview of linear regression. Hope you enjoyed it. I have my email ID as well as our Facebook page along with this YouTube video. Do get in touch. Would be glad to have a conversation with you and understand your individual requirements. And hopefully we'll be able to embellish your knowledge as regards data science to the level required so as to get the job of your dreams, as well as to be a good analytics practitioner. Till then, thank you.